All right, today we are going to dive deep, and I mean really deep, into one of our planet's biggest secrets. We're going on a journey to unearth these massive, hidden oceans of freshwater, hidden away in a place you would never, ever expect. Now, just think about this for a second. What if I told you that right underneath our salty seas, there are vast, hidden oceans of fresh, drinkable water? It sounds like something straight out of a movie, right? But what if it's not fiction? What if it's a reality that could literally change everything for us? So here's how we're going to break it down. First, we'll look at the surprising discovery that kicked this whole thing off. Then, we'll rewind the clock to see how these water relics even got there. After that, we'll jump into the modern tech used to map them. And of course, the big questions. Could this be a lifeline for us? What's the catch? And finally, where do we go from here? Let's jump in. You know, so many big discoveries happen by pure chance, and this one is no different. Picture this. It's about 50 years ago, a U.S. government ship is out at sea off the northeastern coast. Now, they're not looking for water at all. They're drilling for minerals, for oil and gas. But then, their drill hit something totally bizarre. Freshwater. Can you imagine their confusion? For decades, it was just this weird little puzzle, this scientific anomaly, until some modern scientists thought, hey, maybe we should take another look at that. Okay, so what are we even talking about here? What is an offshore aquifer? Well, the best way to think about it is like a giant sponge. But instead of your kitchen sponge, this one is made of porous rock and sediment, and it's buried deep under the seabed. And here's the crazy part. This massive sponge is soaked not with salt water, but with fresh water. And we're not talking about little puddles here. These things are enormous, stretching for hundreds and hundreds of kilometers right under the ocean. This all leads to a massive question, doesn't it? How in the world did all this fresh water get trapped under the salty ocean? I mean, it seems impossible. The answer is just incredible. It has nothing to do with what's happening today. To understand it, we have to go back in time, way back, to the last ice age. We're talking about water relics from a completely different Earth. So, let's walk through how this happened. About 20,000 years ago, the planet was in a deep ice age. So much water was locked up in massive glaciers that the sea level was way lower, by about 120 meters. This left huge areas of the continental shelf as dry land. For thousands of years, it rained on this land, and that rainwater soaked down, filling up those underground sponges. Then, around 10,000 years ago, the planet started to warm up. The glaciers melted, all that water poured back into the oceans, and the sea levels rose, completely flooding that land. Over time, layers of mud and clay settled on top, creating a perfect seal, trapping all that ancient rainwater underneath. That's why they call it fossil water. It's literally a snapshot from the past. Now, super important to understand that there are two main types of these undersea water pockets. On one hand, you have the relict aquifers. These are the ones we just talked about. They are basically time capsules of fossil water completely sealed off and not getting any new water. Then you have active aquifers. These are different. They're actually extensions of groundwater systems on land, so they are still being very slowly refilled by rain and rivers today. Okay, so let's fast forward back to today. Remember that accidental discovery from 50 years ago? Well, it led to something absolutely groundbreaking. A team of scientists from all over the world went back to that exact same area off the U.S. Atlantic coast. But this time, they weren't drilling blindly. Oh no. They came armed with some seriously cool, cutting-edge technology ready to map this invisible world. This mission had a name, Expedition 501. The team was on this incredible research ship, the Joids Resolution, and they started drilling. They went deep, man, sometimes over 1,200 feet below the seafloor, pulling up core samples. And what they found, it was just staggering. They confirmed a single, massive, continuous system of fresh water. It wasn't just a few isolated spots. It was one gigantic reservoir stretching from New Jersey all the way up to Massachusetts and reaching almost 100 kilometers out to sea. So just how big are we talking? Get ready for this number, 2,800 cubic kilometers. That is an almost unimaginable amount of water. Just to give you some perspective, that's roughly the same amount of water as the legendary Ogallala Aquifer, which is this huge underground reserve that waters a massive chunk of America's farms. So yeah, we're talking about a world-class water resource that was sitting right under the ocean, completely hidden, all this time. It's mind-boggling. So you're probably wondering, how do you see something that's buried deep under the seafloor? You can't just look. Well, they use this brilliant piece of tech called marine electromagnetic imaging. Here's the gist of it. They tow a special sensor along the bottom of the ocean. This sensor sends out an electromagnetic field down into the rock. Now here's the clever part. Salt water is full of, well, salt, so it conducts electricity really well. Fresh water, on the other hand, is a very pole conductor. It has high resistance. The sensor measures that resistance. So when it detects a huge area of high resistance, bingo, that's your freshwater. It's like a fish finder, but for hidden oceans.
Okay, all of this science is fascinating, it's amazing, but it brings us to the most important question, the real so what of it all. In a world where water is becoming more and more scarce, what does a discovery like this actually mean for humanity? Could this really be the lifeline we've been looking for?
Well, the potential is just massive. For dry coastal areas, this is a brand new source of water they never knew they had. It's a game changer for resilience, right? You're no longer just depending on rivers that can dry up. It gives coastal cities, where billions of us live, a local, long-term supply. And since it's buried so deep, it's protected from short-term climate shifts. It's like a strategic water reserve. And this isn't just happening off the coast of America. They found similar things off Australia, China, South Africa, and scientists believe there's huge potential along India's massive 7,500-kilometer coastline, a place where a new source of water would be life-changing.
But, and you knew there was a but coming, right? All of this incredible promise comes with a very heavy dose of reality. Getting this water from under the ocean to a tap in your home, that is a long, expensive, and very risky road. This is absolutely not a magic wand we can just wave to solve all our water problems.
The challenges are huge, and they really fall into 4 big buckets. First, the cost is just astronomical. We're talking billions. Second, the technology to actually get the water out is brand new and unproven. Third, and this is a big one, there are serious environmental risks. And finally, there are all these tricky legal questions, like who actually owns this water, especially when it crosses borders. Let's dig into those environmental risks for a second, because this is where things get really serious. If you start pumping out huge amounts of water, the ground above it can literally sink. It's called subsidence. Pump too hard, and you risk saltwater breaking through and ruining the entire freshwater supply permanently. Not only that, but we don't know what kind of marine life depends on the slow trickle of this fresh water into the ocean. We could be disrupting entire ecosystems. And remember, this water has been sitting in rock for thousands of years. It could have picked up nasty stuff like arsenic, which would have to be filtered out. So the obvious comparison is with desalination, right? That's our main way of getting fresh water from the sea now. How do they stack up? Well, using these aquifers would probably take a lot less energy, which is a huge plus. But desalination, while energy-hungry and creating its own waste problems, is a technology we already have and understand. The aquifers have all these new environmental risks we just talked about. And the biggest difference? You can build a desalination plant on pretty much any coast. But these aquifers, they only exist where geology has created them.
So, we have this enormous potential on one side and these profound risks on the other. So where do we go from here? What's the smart way to move forward? Well, the experts all agree on one thing. We have to be incredibly careful.
The responsible path forward looks something like this. First things first, we need to map these things globally to even know what we're dealing with. At the same time, we need to pour money into research to figure out how to get this water out safely and affordably. And this is non-negotiable. Before anyone drills a single production well, there must be exhaustive environmental studies. We need international laws to govern this, and we need to have an open, honest conversation with the public about all the pros and cons.
I think this quote really says it all, doesn't it? It's all about finding that balance between our very real, very urgent need for water and our deep responsibility to protect the oceans. It's a classic head versus heart dilemma, a real tightrope we have to walk. And so, we're back to the big question. We've found this incredible secret, these hidden oceans of ancient fresh water. Are they a lifeline for humanity? A gift from the past that could secure our future? Or are they a Pandora's box? Something that if we open it recklessly, could unleash a torrent of environmental problems we can never fix. What we do next, that choice, and all the responsibility that comes with it, is completely on us.